Hello everyone, I'm Bert and I'll be talking you through some well-known techniques to increase the energy efficiency of neural network implementations. I'll go a bit quicker than the previous talks because I really have those 5 topics to cover, but I'm sure we'll be fine. So first, as an introduction, I'll quickly give an overview of the main challenges we see in trying to embed these neural networks or deep learning onto embedded devices. And I'll also go quickly through this introduction because I kind of assume that for this audience, most of these challenges are well known. So as a quick overview, these 3 major challenges. The first one is that even though these neural networks are very accurate in a number of tasks, they really come at a very high cost in terms of model storage, bandwidth, and number of operations you require per input feature or input pixel in computer vision. A second challenge is that a lot of these applications that we want to embed are required to be real-time and actually have to be operated on very large input frames or very large input images in this context. So usually these 2 challenges are kind of tackled by making specialized hardware, but in deep learning we cannot fully specialize because typical applications still require a support of a large variety of algorithms with different type of data flows and so on. So very briefly, 3 major challenges in deep learning are that we require many operations per pixels. We have to process those pixels in real time, and we have to do that for a large variety of algorithms.